Okay, we welcome to the video or this video where we're going to learn about inverse of functions. Okay, so as usual we begin with definition. The inverse of a function f defined on a set x into another set y is a function which we denote by f minus 1, and it goes from y into x such that when we compose f with f minus 1, so f composed with this inverse acting on x will give us the identity function. Of course, we remember what the identity function does, so this will produce x. Again, if we compose f inverse with f acting on x, it will also give us x. A function f minus 1 that behaves like this is what we call the inverse of the original function f. Okay. It is possible that we can get what we call the left inverse of the function. We can also get what we call the right inverse of the function. Both of them exist, but they are not equal. In that case, that function f has no inverse. All we can say is that the left inverse exists, and then the right inverse exists. But if both the left and right inverse exist, and they are equal, that is equal to x, then we say that that function has f minus 1 as the inverse. Alright, we'll take some examples. Let's consider the function f of x equal 2x minus 3. So we want to find the inverse of the function f. Okay. To solve this problem, let us suppose now, let's call f at x, y, just for ease of notation. So we do this, let y be equal to f of x. And when this happens, we have that y is 2x minus 3. Here, our function f goes from R into R. Okay. So our goal is to find the inverse of f. So if you remember, if we look at the definition we gave, so what we're looking at is we're looking for f minus 1, who goes again from R into R, such that when we compose f with f minus 1 acting on x, what we get should be x. And when we compose f inverse with f acting on x, we should also get x. So that is our goal. And so to do this, observe that y to be 2x minus 3. This will give us that y plus 3 is 2 multiplied by x. And this says that y plus 3 divided by 2 is equal to x. So with this now, we look at f minus 1 as a function that goes from R into R. What this does is for anybody we give in y, in R, let me call it y, I can also still call it x. They're all dummy variables. Both y and x, they're the same, they represent members of the set R. So we can use them interchangeably without confusion, if confusion is not going to happen. So, is a function that goes from here to here such that for any y we give f minus 1 of y is y plus 3 divided by 2. And like I said, I can still write it as f minus 1 of x is x plus 3 divided by 2. So if using y will confuse you, don't worry, write it as f minus 1 of x. Okay. And if we do this, let's check what we're going to get by composing f with f minus 1 and allow it to act on x. Do not forget how we defined composition of functions in the previous videos. So this is nothing but f acting on f minus 1 of x. And this is nothing but f of, who is f minus 1 of x? It is x plus 3 over 2. So have x plus 3 over 2. What does f do to its elements? What it does, it multiplies x by 2 and removes 3. And so this is nothing but 2 into x plus 3 over 2 minus 3, which is going to give us 2 will cancel 2, and then we have x plus 3 minus 3, which is precisely x. So we have composed f with f minus 1, and then what we're getting is x. So we need to do the the left composition of f inverse with f and see if we still get x. If we do, then this function so defined is the inverse of that. So we have f minus 1 of x. By definition, f minus 1 composed with f acting on x is nothing but f minus 1 f of x, and this is f minus 1 of 2x minus 3. Now, we know how f minus 1 behaves. What it does is, for anybody you give him, you add 3 to the person and divide by 2. So here we're giving him 2x minus 3. So this is going to give us 2x minus 3 plus 3 divided by 2. And this is nothing but x. So again, we see that f minus 1 composed with f gives x. Therefore, this function, defined this way, is the inverse of this. Thank you.